Probably. A lot of them are. Oh, that's funny. That's a big kitty. 2 watermelons. That's incredibly specific. That's funny. All right. Well, my friends, I love dogs. I want a dog. I really do. I want like a scruffy looking, like those dogs that you see on TV, like they look like just scruff. I want a scruffy looking dog. Oh my gosh, that's a gorgeous dog. My husband would be jealous. That's what he wants. He wants a German Shepherd. I heard they're really good dogs. They're gorgeous. Husky wolf mix. Wow. That's cool. Yes. Oh yeah. She probably takes off. Great Pyrenees. They're really good dogs. I heard they're great family dogs. Yeah, when I was at the vet, I saw a ooh, well that's cool. I saw a Tibetan Mastiff. Oh my gosh, it was huge. It was like a bear. I was like, a bear. Oh, that's cool that she's at doggy daycare. That's cool. Get that energy out, right? That's what my kids are. My daughter, sometimes she'll play fetch with me. She's like a dog, seriously. And she'll say, "I pretend I'm a puppy." Okay. Oh yeah. That would be a lot. But you're socializing her, that's good. Very good. Ooh, super cute. Oh, is it super noisy over there? Oh, and the barking. The barking, yeah. So that would be a lot. Yeah, that would be a lot. Thai Ridgeback. I'll have to look that up. That's cool. Oops. Sorry, guys. Did that again. Okay, so today we're going to go through one-step and two-step equations. That's it. Not too bad. Oh man, that's funny. He is a little princess. It's cute. Okay, so who has done like traditional equation solving before? Whether it's at your old school or you were here last year and you did it, like who's kind of like done it before? Type let's see, a dollar sign if you've done it before. And some of you have already handed it in. And now I'm going to say with these one-step equations, it's very easy to reason it out. But I want to challenge you guys to think of it in steps. Think of it how I'm going to present it today. Okay, 3 of you have done it before. That's good. Anybody else? Oh, okay, a little more. Okay, cool. Well, it's all opposites, right? You have to look at what operation is going on in your problem and think opposite. And I have a little chart here because, you'd be surprised at how easy it is to confuse some of this stuff. So it has the operation. So, like, if you see addition in your equation, you're going to use subtraction to solve it. If you see subtraction, you would use addition to solve it. So it has all the opposites. Multiplication, division, multiplication. Opposite of square rooting something is squaring something, and vice versa. And if you have a fraction, we think reciprocal. What's reciprocal? Do you guys remember what a reciprocal is? You flip it, right? You flip your fraction. So if your fraction says 2/3, you would multiply by 3/2. You flip it. So it's always about doing the opposite. Okay, so you got to know which operations are your opposites. So, and I feel like the big ones that people kind of forget a lot are right here. Right there. So if you see addition, you would actually subtract to solve all that stuff. Make sense? Makes sense. Makes sense. All right, let's talk about one-step equations. Okay, wow, that one-step equations, that wrote on there really weird. Interesting. All right, so if you guys see this first one, this is where I would definitely grab your notebook and write some stuff down because it helps to see the steps. You probably can already reason it out, right? Just looking at it, what was added to 3 to get you to 8? What would you add to 3 to get to 8? That's kind of like what this is saying. X is your variable. Right, you can look at it and be like, oh, that's 5. But I want you to think steps. Now, when you're doing this in Math Excel, sure, you're probably going to just look at it and reason it out. Totally fine. Remember, X stands for your solution. That's your number that you're trying to solve for. The whole objective is to get X by itself. So sometimes what I do is I'll take my equal sign and oh gosh. Guys, I keep doing this. Jen, come on. Okay. So sometimes what I'll do is I'll draw a straight line to separate the two sides of the equation because your equation has to balance. Whatever you do to one side, you do to the other. So what we're going to do is we're going to look at what's happening on the x side and do the opposite. So it looks like on the x side, I'm adding 3. What's the opposite of adding 3?
Subtracting 3?
Right, very good. That would be subtracting 3. So that's what I'm going to do on both sides of my equation. 3 minus 3, that cancels. So we're just left with x. And then 8 minus 3, that does give you your 5. And it's really good to do what Vlad wrote in there, is to look at it and say, what was added to 3 to give me 8? What do I think the answer should be? Because then we can see if it matches. So you get x equals 5. Cool. Makes sense? Not too bad. A lot of you were already done with this assignment. And some of you were not. You did not have to be. I was just saying, a lot of you were. All right, let's look at this next one. And I'm going to the right. So I'm looking at this x minus 4 equals 7. So I'm going to separate my problem. I'm going to look at the x. Looks like I'm going x minus 4. What's the opposite of subtracting 4? We're going to add 4. Yeah, that's the opposite. That's the thinking opposites here. And let's just kind of think of it, before we solve it. What number do you think they subtracted 4 from to get 7? What minus 4 can give you 7? In my brain, I always go to 10 minus 4, and then I'm like, wait a minute, that's 6. So what number minus 4 actually gives you 7? What do you guys think? And you don't have to think about it this way, but sometimes it helps. So like if 10 minus 4 is 6, what number minus 4 gives you 7? Did I lose everybody? Oh no! You guys still there? Oh, good. Okay, good. I was just checking. Good, good, good. 11. Yeah, you're right. Very good. It would be 11. And sometimes you can look at it and know, and sometimes you can't know. So we're going to do what Marina said. We're going to add 4 to both sides. So we're going to add 4. That's going to cancel. -4 plus 4 is just 0. And instead of writing 0, we cancel it. We bring down what's left over, which is x. And then 7 plus 4 gives me 11. Cool. Very good. And I can double check that. I can see if I'm right by taking that 11 and plugging it into my problem to see if I get 7, and you do. Does that make sense, guys? If that makes sense, could you please write yes or yep? Excellent. Very good. Very, very good. Okay, let's look at the next one. So the next one we have 5x equals 35. So when you guys see 5x like that, what does that mean? What operation are they doing there? They're multiplying, yeah. So we're going to do the opposite of multiplying. What is the opposite of multiplying? 5, I like that. Yep, 5 multiplied by a number. And the opposite is division. Very good. So I'm going to take the number that's getting multiplied by my variable, and I'm going to do the opposite. I'm going to divide by it, because that is going to help cancel it away from my x. Hello, Ava. So I can solve it. So what's 35 divided by 5? 7. Very good. X equals 7. Yep, that's right. And I can double check it by plugging it in. I can go 5 times 7. Does that equal 35? And it does. Totally does. We're good to go. What about my next one here? I got x divided by 3 equals 7. So what operation? It looks like I'm dividing next to that x. What's the opposite of dividing by 3? Multiplication. Very good. We're going to multiply by 3 on both sides. So we're going to cancel that out there. So we have x is equal to, and the reason it cancels is because you have x divided by 3. If you multiply by 3, that's the same as like 3 over 1. And anytime you divide by 3 and multiply by 3, it cancels it out. Just gets that x by itself. So x is equal to 7 times 3, 21. And that is that. Those are all the type of one-step equations you guys would see. Does anybody have any questions on that? Anybody else have questions? Can I just say I really, really appreciate it when people like respond right away, like, wow, so cool. Can totally tell you're listening, and it's awesome. Helps me go quick. Pardon my yawn. Okay, is anybody still writing stuff down? Okay, I'm gonna change it. I'm gonna change it. It's happening. Tell me now. Okay, it's gone. But if you were still writing, let me know, and I'll go back. Okay, so I kind of want you guys to try a little bit. Who would be willing on the first one there to write steps, even one step, like what we should do first? Is anybody willing? Please, please. Here, I'll do one for you. I'll do the first step. Separate our equation, isolate our variable. It's our first step there. Okay, who would be willing to write on there what we should do? What do you think? Ugh. And remember, if you're writing on the screen, I can't tell who it is. So if you get it wrong, it's like, who cares? Oh, sweetness, you're awesome. Thank you. Look at that. That's perfection. We have x plus 5. We want to get rid of adding 5, so we subtract 5 from both sides. Very good. And is it okay to use a calculator? What do you guys think? Is that okay with me? Take it, Jen. Sorry. Absolutely, yes, it is okay to use a calculator because your brain is focused on the steps. So if you need to use a calculator to just double check your math, that's smart. I think that's totally fine. So this is perfect. So we subtracted our 5, we canceled it out. And x is going to be whatever negative 17 minus 5 is. Negative 17 minus 5. What is that, guys? It's like saying, I owe you guys $17. Oh, Jen, and then I owe you $5 more. How much do I owe you? $22. That's right. I got to get my act together. Jeez, Jen. That's perfect. Very good. Let's look at this next one, going across to the right. This is where it really helps to draw in the wall of the equation, kind of separate it out right under the equal sign, and then locate your variable. Because what's weird about this one? Why is this equation kind of a weirdo equation? It's flipped, yeah. It's flipped. They've just flipped where the problem and the answer are. And it's not a problem. I would not flip it back because it's too easy to confuse where the negatives go and all that. I would leave it, but I would locate that variable because now on the variable side, what's going on? It looks like we're going x minus 3. So what would I do to both sides to solve that? If I'm already on the variable side going minus 3, and remember the variable side is wherever the x is. So this is the variable side. Okay, no problem, Nathan. What am I going to do? What's the opposite of subtracting 3? Because we got to do the opposite to cancel it out so we can figure out what x is. What's the opposite of subtracting 3? Add 3. Very good. We're going to add 3. So that's going to cancel. And then we're going to bring down what's left. And then what's negative 15 plus 3? It's like saying, I owe you $15. I owe Marina $15, and I only have 3 to pay her back. So do I still owe her money? I owe her $12. Very good. Nice job, guys. What about the bottom one there? Nice job, Marina. Yeah. I'll pay you back your money someday. No. What do you guys think? What am I doing there? A lot of people might say subtracting 3, and they would be incorrect because you got to look at what's going on between the -3 and the x. What do you guys think? What operation is going on there? What do you think? Multiplication. You're right. A lot of people get confused because of that negative and they think that we're adding. Or excuse me, we're subtracting, and we're not doing that. Whenever you have a variable right next to a number like that, you're always multiplying. Okay? If you were adding or subtracting, you would have a sign in between the variable and the number. So we are multiplying. So what do we need to do to solve it? We need to divide. You're right. So we're going to divide. Hi, Nathan. Thanks for coming back. We're going to divide both sides by, now some people, they think that they have to take the opposite of the number, but we don't want to do that because then the negative will still be there. So we're going to divide by -3. So x is whatever 8 divided by -3 is. That's probably going to be a fraction. So we're just going to leave it as 8/3. And see how the negative is in the bottom? We're going to move the negative out front or put it with the numerator. And that's our answer. It's okay to just leave it as the fraction. It's actually more accurate that way. Questions on that one? All right. Last one of the one-steppers. All right, I'm going to focus on the variable. So now what operation is going on that side? What are they doing there? What's going on between, yeah, we see division. You're right. Very good, Marina. So we see division going on there. Now I want to get rid of the 4 and the negative. So we're going to do the opposite of division, which is multiplication. Good. Nice job. You're like reading my mind. So if I want to get rid of the negative and the 4, then I'm going to multiply by -4. Even though it looks like that negative is out front, that's okay. We can slide it with that 4 and make that 4 a negative. So we can multiply by -4 just to get rid of it. So we're left with x is whatever 6 times -4 is. What's 6 times -4? -24. Very good. All right, I want to know how this is going. Emma, Ava, Marina, all you guys. Marina, I kind of get a good sense of how it's going for you because you're answering and you're kicking butt. Yeah. Emma, you too. Audrey, Evan, Vlad, Cade, Ayub, Nadia, Chase, Freya, Nathan. How are we doing? Yep, Emma, I got a sense of that. Kicking butt with answering. Woohoo! Okay. Is it making sense? Is it like, I got this? It's easy peasy, lemon squeezy. All right, good. All right, we're going to talk about two-steppers. Two-stepper equations really quickly. Not super quick, but like this is the last thing we're talking about. So, important thing to know, if you didn't, is the parts of an equation. Definitely write that down, okay? The number in front of your variable is called the coefficient. Okay, it's always next to the variable. The coefficient is always right next to that. The constant is the plain number on the x side of the equation, excuse me. Technically, the answer is a constant too, but usually I refer to that as the answer because it's the only number on that side. And then the operator is what's going on in the middle. So it's either addition, subtraction, all that good stuff. Okay, so coefficient, the two main words that you guys gotta know are coefficient, which is the number in front of the variable. Variable is also an important one, but I feel like you guys already know that. So coefficient, number right next to the variable, and constant is just the plain number in the problem. There's no variable attached to it. Okay, so coefficient and constant, those are the ones we really need to know. Okay, write it down, write it down, write it down. It's like in Blue's Clues. I love that show. You probably don't know where that show is. I have dated myself. That's okay. Oh, good. Very good. It's a big 90s show. All right. You guys know it. That's awesome. Yeah, my son was pretty hooked on it. Still is. Still is. Marina, yeah, that's awesome. Good job, guys. All right. Yeah, it's a good show. Yup, blue dog. Bow, bow, bow. Okay, I won't be blue, I promise. Okay, so we're gonna undo the steps of this equation, okay? So this, I want you guys to write down. Make sure you have it. Pretty please with sugar on top. Thank you. Okay, so we're gonna draw in the line underneath that equal sign just to get a sense of each side of our equation. And then we're going to identify where the variable is. I always like to put a little mark on it in some way. So whenever you guys do this, you're going to focus on the constant first, and we're going to make a note of that. We're going to undo the constant first. Ah, dang it, Jen. Okay, sorry. So we're going to undo the constant first. So the constant, what part of this equation is the constant? What do you think? The 2, yes, the 2 is the constant. So that's what we take care of first. And it looks like we're adding 2. So what's the opposite of adding 2? Subtract 2. Very good, guys. So then we bring down what's left. The 2's cancel. So I'm left with 3x equals 12. Now we do the coefficient. Now our step is to undo, whoops, not undo, undo the coefficient. That's what we'll do. Okay, so what is the coefficient here? Which number is our coefficient? the 3. Very good. So the opposite of what's going on there, multiplying by 3, is to do what? What's the opposite of multiplying by 3? Divide. You got it. Good job, guys. We're going to divide by 3. So we are left with x equals 4. Good. And I can check that I'm right by plugging it back into the equation. I can go 3, here's my x. Now my x is going to turn into a 4 plus 2. Does this equal 14? Well, this is the same as 12 plus 2, which definitely equals 14. Questions on that? Any questions? We first undo the constant, then we undo the coefficient. All right, good work. All right, what about this one? I'll first get it all set up, get it prepped. Okay, we're gonna undo the constant first. Which one's our constant? The 6, very good. And I am adding 6, so what's the opposite of adding 6? Yeah, very good. We're gonna subtract 6. Very, very good. So the 6's cancel, and I'm left with a over 3 equals 2. Excellent. Now I'm going to get rid or undo the coefficient. In this case, the coefficient actually is a 1/3. This one's kind of weird. So, but you don't have to really worry about the whole fraction thing. Just look at the fact that we're dividing. So what's the opposite of dividing by 3? We're going to multiply both sides by 3. Yeah. So that's going to cancel, and I'm left with 6 equals A. Very good. Is this making sense? Friends and neighbors? All right. If not, let me know. Okay, so friends, I'm going to go ahead and prep my problem. Can I get someone to do my first step here, which is undoing that constant? What do you guys think? Or first, maybe we should say, where is my constant here? Oh, beautiful. Thanks, Emma. So we're going to undo the constant. Yup. By adding 5. Very good. Perfection. That's right. So that cancels. And we're left with 8c on this side. 43 plus 5 is 48. Now we got to undo the coefficient. Who will show undoing of the coefficient? What do you guys think? So it's looking next to the variable and saying, oh, okay, we're going 8 times c. What's the opposite of multiplying the c times 8? What's the opposite of that? What do you guys think? I'm going to take a toaster strudel bite. Num. Yeah, dividing. Good job, guys. So can someone show dividing both sides by 8? Dividing by 8. Remember, it's just the fraction bar. Awesome. Thanks, Emma. Yep. That's perfect. And why are we dividing by 8? Why does 8 go on the bottom and not 48? It's a common mistake. Who knows? For bonus cool points today. For all the cool points. I have a lot to award because I'm pretty cool. I'm just kidding. Why are we dividing by 8 and not 48? Yeah, very good. 8 is the coefficient. That's totally it. Emma gets all the cool points. Very good. It's done. But yeah, 8 is the coefficient. 8 is the number we're trying to get rid of because we want to get that variable by itself. Good. So we're left with the 8's cancel. We're left with C equals 6. And that's our answer. How is this going? Is it making sense? If it's making sense, who left? Oh, man. Okay, you guys will have a question like this in your homework. Just remember when they have you do something like this, so they're saying determine the value of D to make the statement true. In the equation 7D plus 3x equals 20, the solution is -2. So if they're telling you the solution is -2, what variable are they giving you? Are they giving you D or X? They're giving you X, yeah. So when you do this, you're going to want to first plug in that solution for X. So you're left with 7D minus 6 equals 20. And this is what you're going to solve to find D. Does that make sense? Friends and neighbors? All right. So I have 2 more examples. If you would like to go through those 2 more examples, you may stay. But if you are feeling good, like you're ready for that homework and you want to give it a try and let me know, go for it. Otherwise, that's all I have for you. You're free to go. I'll draw you a flower. Bye. Have a good day. Thank you. Have a good day. Yes, if you would like to stay, we can keep working on examples. But if you're feeling good, you are free to go.
Was it all right for me to finish everything?
Oh,
like,
yeah.
A couple days before? All right.
Yeah. Is this making sense?
Well, yeah, that's why I finished everything.
Makes sense. No, that's fine. That's totally good. Totally
All right.
good.
Got it. Well, bye.
All right, bye. Bye, Ava. Freya, how we doing? Bye, Freya. I saw you wrote bye. Bye. I'm drawing pretty pictures. Oh, I should probably stop recording this.